So here it has been told to prove that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So we have to prove it. So it is given. So we draw a quadrilateral CBCD and whose diagonals bisect each other. This is the diagonal AC and this is the diagonal BD and the intersect at O. So it is given that the diagonals bisect, so AO equal to OC and DO equal to OB. So we will write what is given. So given is in quadrilateral BDCD, the diagonals AD, AC and BD bisect each other at the point O. Bisect each other at the point O. Bisect each other at the point O. That is, you can say that OA equals to OC and OB equals to OD. OB equals to OD. So then we have to prove that ABCD is a parallelogram. ABCD is a parallelogram. The proof is given as, so you can say that in triangle AOD and triangle COB, you can say that AO equals to CO, which is given, and also OB equals to OD, which is also given, and angle AOD that is equal to angle COB, since vertically opposite angles are equal. Vertically opposite angles are equal. Therefore, I can say that triangle AOD that is congruent to triangle COB by side angle side, that is by SAS rule of congruency. So therefore, I can say that angle DAO that is equal to angle BCO, and also AD equals to BC by CPCT. So now we can see that, and now I can say that AD is parallel to BC. AD is parallel to BC since these alternate interior angles are equal. Since alternate interior angles are equal. Alternate interior angles are equal as and obviously AC is the transversal. So I can say that since alternate interior angles are equal and AC is the transversal, so AD should be parallel to BC. So therefore, we can say that in quadrilateral ABCD, AD is equal to BC and AD is parallel to BC also. AD is parallel to BC since it is proved earlier or proved above. So we can say that ABCD is a parallelogram. ABCD is a parallelogram. Since why? Since one pair of opposite sides are uh, parallel and equal. Since one pair of opposite sides are parallel and equal, so ABCD should be a parallelogram. Since I will say, since the reason is since one pair of opposite sides, are parallel and equal. So hence proof. And here it is told the lines, we have to prove that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is half width. So this is also called the midpoint theorem. This is also called the midpoint theorem, which you have to prove it. So here we can take one triangle. The triangle is suppose ABC. Suppose D is the midpoint of AB and E is the midpoint of AC. Then we have to prove that the line segment DE is parallel to BC and DE is equal to half of BC also. That will prove. So here what we can do, we can extend ED, and through B we can draw one line which is parallel to CA. They will intersect at F, suppose. So then we have to show that D is equal to half of BC and DE is parallel to BC. So now here we have to write first what is given. Given is B and E are respectively the midpoints. B and E are respectively the midpoints of the sides AB and AC of triangle ABC. And then we have to prove that the line segment DE is parallel to BC and DE equals to half of BC. So here we need one construction. The construction is um, a line is drawn through the point B. Line is drawn through B, which is parallel to CA. It's parallel to CA, which intersects ED extended at the point F. So now we have to write the proof. The proof is that now in these two triangles you can see these two angles are equal since they are vertically opposite angles, and AD equal to DB also. And we can also say that this is equal to this since they're alternate interior angles. Since BF is parallel to EA, which is according to the construction. So by ASA rule, by angle side angle rule, we can say that these two triangles are congruent. So now here you can say that in triangle ADE and triangle BDF, ADE and BDF, angle ADE equals to angle BDF. Since why? Since vertically opposite angles are equal. Vertically opposite angles are equal, and also angle BDF, that is equal to angle DAV. Since why? Since alternate interior angles are equal, as BF is parallel to EA to the construction, according to the construction, according to construction, and AD is equal to BD, BD is equal to DD, since it is given that D is the midpoint of AB. So therefore, I can say that triangle ADE is congruent to triangle BDF. Triangle ADE is congruent to triangle BDF by ASO rule, by angle side angle rule of congruency. Since we have shown that two angles and the included side are equal in these two triangles. These two are also equal, since D and E are the midpoints of AB and AC. So by ASO rule of congruency, triangle AD is congruent to triangle BDF. Now, therefore, I can say that DE equals to DF, DE equals to DF, and obviously this AE equals to BF. AE equals to BF. AE equals to BF. So D, we have proved D is the midpoint of EF. So now we can say that now AE equals to CE also, since it is given that E is the midpoint of AC. So therefore, we can say that AE equals to BF, which is also equal to CE. And also, so AE equals to CE and BF is also equal to CE. And also we can say that BF is parallel to CA, or I can say BF is parallel to CE. Since why? Since according to the construction. According to construction. So hence we can say that in quadrilateral, hence in quadrilateral BFEC, quadrilateral BFEC, BF is equal to CE, BF is equal to CE, and BF is parallel to CE also. BF is parallel to CE, since why? It is proved earlier or proved above. Proved above. So hence we can say that hence BFEC, hence you can say BFEC is a parallelogram. BFEC is a parallelogram. Since why? One pair of opposite sides are equal and parallel. Since one pair of its opposite sides, are parallel and equal. One pair of its opposite sides are parallel and equal. parallel and equal. So therefore I can say that BC is parallel to FE. BC is parallel to FE and BC also equals to FE. BC also equals to FE. Since why? Since I can say since each pair of opposite sides in a parallelogram are equal also and parallel also. Since each pair of opposite sides, in a parallelogram are parallel and equal. Are parallel and equal. And also we can see that also DE plus DF, DE plus DF is equals to EF. Yes. And also DE equals to DF. D equals to DF, which is proved earlier or proved above. Here also we should say DE, we have shown DE is equal to DF and we have told A is equal to BF. The reason also we should tell, that is by CPCT. Since we have shown that triangle AD is complement to triangle BDF. So you can say that, so DE equals to DF, which is equal to half of EF. And which will be obviously equal to half of BC. So we have shown that DE is equal to half of BC. And also, so BC is parallel to FE, or I can say that BC is parallel to DE. So therefore, we can say that DE is parallel to BC and DE equals to half of BC. So hence proof. Hence proved. So hope all of you understood the proofs of these theorems and also the midpoint theorem. So in the next part, we shall prove the converse of the midpoint theorem, and in the proofs of all these theorems and also in the solutions of the exercise questions. Any doubts if you have, then please write that in the comments. We shall obviously clarify them. So thank you everyone. Bye.